Controlled Environment Plant Production Engineering and Technology Education Modules. The worldwide technology for controlled environment plant production. I'm Gene Giacomelli from the Department of Agricultural and Biosystems Engineering at the University of Arizona. I'd like to provide information about technology related to controlled environment plant production and how it relates to the bigger picture for helping to resolve world global issues related to food, water, and energy. Greenhouses can provide food crops as well as ornamental and floral crops, so it can help feed people. Greenhouses can conserve resources such as land space, water, nutrients, and improve labor efficiency. And greenhouses can also reduce the environmental impact potentially caused by in-field agricultural production. And thus, the world has developed these controlled environment technologies we call greenhouses to help meet their needs to produce food and to save energy, water, labor. What we'd like to get an understanding from this presentation is why greenhouses are built in a specific way that they are, and how their design is influenced by the crop that's produced and the local environment that the greenhouse must overcome to provide the proper environment for growing the crop. Also, that a workable greenhouse design includes the structure, the glazing on the structure, and inside a plant growing system and an environmental control system. And finally, that it requires proper management procedures. That is, you need a grower who understands the crop being produced and the ability to manage its environment and the people who will work in that environment. Finally, that the economic greenhouse design is not only a workable design, but it's a workable design that's integrated with a local market demand. You produce the product and you're able to market and sell the product. Greenhouses have been available and used for more than 2,000 years, since the time of the Romans. In more recent years, within 50 or 60 years, there was a shift toward modern controlled environment agriculture and soilless culture production practices using science and engineering technology for producing the crop. Yet only 20 years ago, society began demanding consistent, safe, high-quality foods and ornamentals year-round. And thus, particularly in the United States, the greenhouse industry began to grow quite significantly. The remainder of the world, many parts of it, had already been utilizing greenhouses to produce their food and floral products. Today, controlled environment and soilless culture technologies are well established in production agriculture. They do not replace field production agriculture, but they complement it. And they can offer some very specialized, high quality, in-demand food products. In the future, we expect that plant production systems will become even more sustainable than they are at this point in time. What can a controlled environment greenhouse do? It can provide crops to meet a market demand. It can have and develop new crops for new markets. It should be based on science and engineering technology to be the most efficient, to improve resource utilization, and to reduce environmental impacts. In the process, improve labor conditions compared to field production. Plants are directed by their genetics, but they're modified and respond to their environment, wherever they're grown. And that's what a controlled environment greenhouse can do to help improve the requirements for humans for plant life support on Earth or wherever they may go. and thus the universality of controlled environment agriculture. We'll look around the world and begin with European greenhouses. Plastic greenhouses and high tunnels are indicated here, with Spain, Italy, and Turkey having large amounts of greenhouses and high tunnels. Holland with many 10,000 hectares of glass houses. Spain, 90% of their greenhouses being vegetable. Here's the data. I won't go through it, but it's available for you to look at. Italy, Spain, and Turkey appear in this graphic in huge numbers of hectares of greenhouse production of food. Low tunnels as well. Italy, Spain, and France contribute significantly in the production of food in Europe. Let's look to Italian greenhouses. This is a vegetable grower of tomatoes in the lower picture and an empty greenhouse in the upper picture. But it's a low technology, single polyethylene film covered structure, low cost, growing directly in the soil. Here's a taller greenhouse, gutter connected, again a single layer, plastic film covered, with only natural ventilation in the roof, no electric power for fans for cooling, no heating involved, growing radishes. A zucchini grower, also with a low-tech greenhouse, single layer poly, gutter connected, not very tall to the gutter, maybe only 2.5 meters. The zucchini grown in the soil within the greenhouse, and the product shown beautiful on the lower left. The regions of Italy include those south of Rome, primarily Latina province, Campania and Bari provinces, and then the island of Sicily. Spanish greenhouses. The Almeria region of Spain with 30,000 hectares in one location adjacent to the Mediterranean Sea and backed up against the mountains, as you see in the background. A continuous sea of white-looking greenhouse covered with polyethylene film. A closer picture of the Parral design, which is a cable and wire supported horizontal or flat roof with no electric power, no ventilation, except you see very little in the center here, these black lines where some openings had been cut. The idea is that ventilation is minimized, grown only during the seasons when they're trying to conserve as much heat as possible, and shut down during the summer period. From space, we see that the Almeria region has grown in number of greenhouses since 1974, over a 30-year period, to fill in that region adjacent to the Mediterranean with its good climate conditions and backed up against the mountain regions, having, for the moment, sufficient water for irrigation and no additional resources except labor required. The Dutch greenhouse. One picture. Traditional Dutch glass design. A beautiful, high technology, glass covered structure, relatively tall for good environmental control, with heating at the ground level, within the crop canopy, and up near the gutter level, with screening possibilities for reducing energy loss at night or light transmission in the day, and with a top drip irrigation system where the nutrients runoff are collected and reutilized and provided back to the plant. A classic, typical, used around the world, having been marketed very well by the Dutch high technology greenhouse and hydroponic producers. Turkish greenhouse. These locations are shown here in the Mediterranean region with high technology, as well as the lower technology grown directly in the soil greenhouses, as is indicated in the pictures on the left. Low technology, simple structures, low cost, growing in the soil with almost no climate control, really a rain shelter, and at most anti-frost heating, which is under the dire cold conditions, you bring in a temporary heating system. And no integrated pest management. Synthetic chemicals are a must to keep insects and diseases under control. However, Turkey has higher technology greenhouse with greater investment, and of course, greater yields come with the greater investment. Steel structure using glass or multiple layer polyethylene covers, using hydroponics and integrated pest management techniques for controlling insects and diseases, with the potential for full automation of the climate, of labor, and of irrigation. Chinese greenhouses. China is the largest greenhouse producer in the world, with more than 5 million hectares of greenhouses and tunnels. They have several types: the plastic, lowest cost tunnel house on the left, the solar greenhouse that we will look at in detail in the center, and the closer to traditional Dutch glass houses on the right. This graphic indicates the number of each type of the glass house, the solar house, and the low-cost tunnel, seeing that the tunnel is the largest with very little of the modern multi-span glass house, such as the Dutch Venlo type, but that it will be increasing. As we see here, in the late 1980s, China began using greenhouses, and it wasn't until the late 1990s that they really began to increase, and in the 2000s now, it's just dramatic increase in use of growing fresh vegetables nearby their major cities, for example, like Beijing. This is the Chinese solar greenhouse. It essentially is a solar collector facing south with a rigid wall on one side and the black cover on top as an insulated mat that is unrolled in the nighttime and re-rolled to open to sunlight transmission through the clear plastic cover during the day. Here's a diagram cross-section of it indicating the north wall that's ceramic or concrete wall to insulate as well as to absorb energy during the day. Then the insulated north roof region, plus then the aperture, the glass or plastic facing south, to create the solar collector and greenhouse effect to heat the inside air. And crops then would be grown in the earth, in the soil, without hydroponics. Up here is indicating that mat that they can roll back at the nighttime for insulation and then re-roll it in the day to allow light transmission. A very simple, practical design Chinese solar greenhouse used very, very much for growing fresh vegetables. This is a list of those different areas of the Chinese solar greenhouse that I just described. Here's a picture of an array of the Chinese solar greenhouse. Here's a tall crop, looks like tomatoes, the south-facing glazing, the concrete end walls, and the insulation mats that are rolled up during the daytime. An entire field of these greenhouses can be seen to the horizon. Inside, these are young tomato seedlings that have been transplanted through a clear plastic mulch on the soil to warm the soil and to keep moisture in. And then they will grow up supported from below to produce the tomato fruit. Another image emphasizing the steel frame support that is holding the plastic film glazing to create the roof and the south-facing wall for light transmission, and the north wall, in this case, again, a masonry type wall insulated to absorb some of the heat during the day and release it at night. And there's no additional heating available in these greenhouses. The United States greenhouses. The two ranges go from the high technology on the left to the low technology and lower cost high tunnel greenhouse technology. The high technology is very much like the Dutch design. It might be glass, or it could be double layer polyethylene. In this case, growing tomatoes hydroponically in a multiple bay gutter connected greenhouse in Arizona. The high tunnel greenhouse technology has become very popular in recent years, and there are thousands of acres of them now, low cost, no electric power necessarily needed. It's cooled and ventilated by rolling up the sidewalls. It's irrigated by water pressure through a drip irrigation system, and there's typically no heater. Irrigation then is provided to the soil where the plants are grown directly in the earth. In this case, it's single layer polyethylene, the lowest cost system possible. If we look at the extent of the technology in the U.S., the high technology, as we just saw, and the high tunnel, number 1, and then number 3, there is a semi-closed greenhouse system indicated in number 2 that increases yields tremendously. However, most of our greenhouses are in the medium technology range, number 4, which will indicate climate control, heating, as well as fan and cooling, ventilation, with automated irrigation systems. The future remains to be seen how our technology will evolve. However, we know number 3, the high tunnels, are being used by many, many growers growing small numbers of acres under each greenhouse. An example of Nature's Sweet greenhouse in Arizona. This is one block equivalent of 45 acres of gutter-connected greenhouse. This is the Dutch glass design. When put together after the number 2 through number 6 zones were built at the Nature Sweet greenhouse site, a total of 272 acres, we see that ultimately the final size, number 6, was about 55 acres, centered around a building in the middle here for a packing area, a transplant area, and a shipping receiving area. The locations for these larger scale 50 to 100 plus acre greenhouses are shown in this map, most of them being along the southwestern border of the U.S. and into California, Nevada, and now up into Utah, and one out in Maine. There will be more in development. In the Northeast is becoming, particularly in the Ohio area and Michigan area. The next 2 slides offer some details about each one of those high-tech greenhouses and providing that data about their production yields. Most of them are with tomato. Some offer other crops such as cucumber and sweet pepper. And one of them, or more now, are looking to be organic producers of tomatoes using organic fertilizers, not the inorganics. And that's becoming more popular as we go into the future. The village farm design called Gates is a semi-closed greenhouse, and I wanted to indicate that it made a major impact. It changed the yield from 61 kilograms per square meter per year to 100 kilos per square meter per year in a side-by-side comparison of the closed or semi-closed greenhouse to the traditional Venlo greenhouse. Same grower, same variety of tomatoes, and a major increase in yield because of the design. And the belief is that there's more optimum light and carbon dioxide regime and vapor pressure deficit to provide increased productivity and resource use efficiency by the plants, and thus the increase in crops. Tomatoes are the most popular products grown in a greenhouse because they have been most cost effective to grow, and you can see that it was the mid to late 1990s when it began to increase in North America, in the US, Canada, and a little bit in Mexico. And then since 2000, Mexico has grown tremendously, while the US and Canada has stayed approximately the same. Finally, your takeaway. I hope that this brief discussion was able to provide a recognition that controlled environment agriculture is having and will continue to have a global impact on food production throughout the world, and thus making it a very valuable and important area of study for our students and for our growers to continue in the commercial production of fresh vegetables in controlled environments. Thank you very much.